either 1,2 or 1,4. And so I talk about terminology here. 1,2 is called simple, whereas 1,4 is called conjugate addition. And I want you to look at all these slides. I'll probably see if I do a pre-lecture on this stuff this afternoon. I talk about why, and then I go through some of the nucleophiles that do either 1,2 or 1,4. Again, I want you to kind of do that. The new reaction in this section is called the Michael reaction. Okay, so we'll talk about that. So you can see different cases of that. Then we look at a different family of them. These are systems that have activated systems. So notice this is an ester and a ketone. Here I have a cyano and a carbonyl. Can you recognize that this is the most acidic proton? And because this is the most acidic proton, this is going to form the enolate. So again, that's why I want you to start applying this idea of identifying the most acidic proton, because in this chapter, once you identify the most acidic proton, you're going to treat this with an alpha beta saturated system that's either going to go through 1,2 or 1,4 addition. Okay, and so we're going to look at that. Here's a problem that I would like to do in class with you. If the document camera works, notice that as I promised, here's an epoxide that we're going to use in the electrophile. Okay, so we're going to reopen it. That's going to make this type of ring. Can you guys start to practice some of these mechanisms even before I do it tomorrow? Okay, notice this last step is a beta ketoester. You hydrolyze this, you heat it up. This was the last step of the malonic ester synthesis, the decarboxylation, to make this lactone. So again, it's an opportunity for us to apply multiple chapters in chapter 24, which is a culmination of all the chemistry you've learned up to this point. Okay, and now that you've seen that, can you use this methodology here to make these derivatives? So can you apply what we just did in the previous slide by understanding the mechanism? Can you use that mechanism to now ask the question, how would I synthesize this? How would my starting material look different to prepare this one from that one? Okay. Here's another example of questions I could ask on an exam. So here is basically looking at this, giving me the intermediates. Here is a conjugate addition reaction using an enamine. Okay, so you should have learned enamines early in this with Dr. Schwann. Now we're applying them in this 1,4 conjugate addition reaction. Okay, so again, here's some more. And then we're going to culminate with a really cool reaction, which is called a Robinson annulation. And Robinson won a Nobel Prize for this work. He was a great synthetic chemist. And it's an annulation reaction that creates rings, and specifically rings that are fused to one another. What's really cool about it is that the first step of this reaction is something that I'll teach you guys tomorrow called a Michael addition, and this last step is an aldol. So we're putting together, to make this really cool ring system here, a reaction that we're going to learn tomorrow, and then a reaction that we learned yesterday. Okay, and so we're going to look at, here's another example of that we'll talk about. And again, I was really hoping to use a document camera, and that's why I have the problems like this. So again, I need to rectify that, because if not, I'm kind of in trouble in my strategy of teaching you guys at this point. One of the last reactions we're going to do is a reaction called a manic, and it's a 3-component reaction. It involves a ketone, aldehyde, and amine, and it makes this type of species. So I just want to introduce you to that and just have you guys see the utility of this reaction based upon some of the mechanisms you've learned up to this point. Okay, this is different systems, and at this point, that's where I'm at. But again, it's not very long. I think it's only 23 slides.